Good morning. Welcome to the construction site where we will be installing a mechanical ventilation heat recovery system. This is a timber frame building using modular technology, so everything is made entirely out of wood. The installation design includes a supply and exhaust system, with a technical room shown in the plans where the heat recovery unit, the EZV recuperator, will be installed. It will be installed in the corner. On one side, the air intake will be connected. A filter box with a preheater will be installed on the intake duct. The exhaust duct will go directly through the next wall. Meanwhile, on the supply and exhaust sides, we will install distribution boxes connected to the recuperator via flexible silencers. And we have the entire air distribution system with ducts and pipes laid out in the space above the suspended ceiling. Meanwhile, from this suspended ceiling space, for the ventilation of the upper floor, we will run into the walls that are installed above, and the supply and exhaust vents will be placed in the walls of the rooms, the bathroom, and above the mezzanine. So that's how we start the whole process. In a moment, the installation will begin. With the preparatory elements, meaning cutting out the openings for the intake and exhaust grills. The heat recovery unit will be mounted on a plate on the wall, while everything else will be installed on brackets under the ceiling, in the space above the suspended ceiling. So that's the plan when it comes to installing the heat recovery system in this building. In this kind of technology, meaning a timber frame, wooden construction. Preparing the route for the 75 mm diameter ducts, cutting the beam under the ceiling. Preparing the spot for installing the heat recovery unit, mounting the board on the wall to which the unit will later be attached. Marking the location for installing the distribution box, for both the supply and exhaust, and preparing the structure for their installation. Marking the spot for installing the wall bracket to mount the heat recovery unit on the wall. Marking and preparing the spot for installing the filter box with the preheater. Preparing the area for making the opening for the intake grill. Installing the wall bracket for the heat recovery unit. Marking the location for the exhaust duct opening. Marking the spot for the intake duct opening. Installing the EPS pipe for the intake duct. Ensuring continuity of wind and vapor barriers on the wall. Installing the EPS pipe for the exhaust duct. Mounting the distribution manifolds to the ceiling. Installing the ceiling-type plenum box with a nipple stub. Installing brackets for the 75 mm ventilation duct. Installing ventilation ducts connecting the manifold to the plenum box. We're upstairs in a timber frame house, where we also need to install ventilation and heat recovery. And here, in a timber frame building, we actually have the option to use the partition walls of the building to install the plenum boxes. The installation from the distribution box runs through the space of the suspended ceiling from below, and we go in. Right into the center of the wall, making an opening. Here it's very simple, just in the plasterboard, and we go into the wall so that we can install the box, where the manifold box will then be flush with the wall, and you can immediately mount the grill for the air diffuser there, whether it's for supply or exhaust. The same solution has been used in the rooms. Here, it's actually the supply air going into the room. But further down, in the middle, there's also a bathroom where it will be done the same way. Here as well, because this building has a mezzanine, meaning we have an open space above the living room in order to remove the warm air that will rise up, among other things. Also from the kitchen or living room, there's an exhaust box installed here by the stairs. To balance the system, but also to remove that warm air that will be rising upwards. So this is also organized within the wall, although there is a bit of an inconvenience here, because right underneath runs the main structural beam, so we had to make the holes for the ducts next to the beam, but we still managed to fit everything inside the wall. It could have been done differently if the conditions were different. For example, if there was more height in the floor, then we could have routed the installation through the floor or done something else. We also could have, for instance, used a box, a conduit connecting the distribution boxes, for example, to the room, and also tried to do it from the ceiling. But these are additional elements, extra complications, which aren't necessary in this building. We have a great opportunity to use the wall, and underneath we have a suspended ceiling where we can freely run these pipes between the manifold and the plenum box. So that's how we can do it in this building. In wooden frame technology. We'll use diffusers in the bathroom, mounted in the wall, while for the rooms we'll install grills, ventilation grills, so that the air can flow into the room. If we used a diffuser, it would distribute the air along the wall, and the air would flow downwards. And what we care about is ensuring circulation, so that the air can move around in the room. So, ventilation grills will be installed in the rooms. Installation of the filter box and connection to the intake duct. Installation of the EZV302 heat recovery unit on the wall. Connecting the heat recovery unit to the intake and exhaust ducts as well as the distribution boxes, with the distribution boxes and the exhaust duct connected via a flexible silencer. We have installed the EZV302 heat recovery unit, which is a type we haven't shown before in our videos. Here, we have the heat recovery unit installed in a timber frame building where it has been properly selected and planned, meaning we have the L version, so the intake duct is on the left side, and the intake duct is connected via a filter box with a preheater to the intake grill mounted in the wall. Here, to ensure the building is properly airtight in terms of air permeability, there is a special membrane on the wall. So we also had to properly seal this opening in the wall to keep the building airtight. So we have the intake grill. Here, in this spot, the exhaust vent is installed, which means the heat recovery unit is also connected to the exhaust grill. And here, because the section between the heat recovery unit and the grill itself is very short, a solution was used in the form of a third flexible silencer, because usually we recommend, suggest, or sometimes require that a silencer be installed between the heat recovery unit and the supply and exhaust manifolds. And that's exactly the case here, where we have two flexible silencers installed in this third location. But as I mentioned, since there's only a short section to the exhaust grill, there's also a third silencer installed there. So, we have it set up accordingly, because we're in the technical room, where the EPS duct has the appropriate thickness of insulation, which protects the installation from condensation forming on the outside of the pipe, that is, inside the room. So in this case, in this room, which will be in the warm zone, that is, it's heated and insulated, the EPS duct is completely sufficient for us. However, the rest of the installation from the manifold to the individual plenum boxes uses Peflex ducts with a diameter of 75, running through the space of the suspended ceiling. So when it comes to the installation itself, the recuperator is mounted on a wall bracket, suspended on the wall, with the lower basket where the heat exchanger is attached to it. That's how the installation of the Easy Series recuperator looks EasyV, meaning with the connections facing upwards.